Through all the noise and philosophical debates surrounding STEM education, one common goal of every educator is to equip students with foundational skills for use in successful and fulfilling careers.
As industry professionals, we are bombarded every day with information, distractions, and conflicting objectives.
Flexibility and agility are critical to excel in the modern workforce, where cross-functional collaboration and effective communication are paramount.
We design all Milestone C programs for students to learn, practice, and refine these skills.
In order to provide a crucially important framework that's common and standardized across all of our programs, this video describes Milestone C's trademark curriculum design model to shape future STEM leaders.
It is called nonlinear learning. The bottom line is that the human mind retrieves information much more effectively in the context that resembles the original learning environment.
Therefore, our programs create learning environments to teach students in the same context that they will apply the subject knowledge and skills.
All Milestone C curricula are designed with activities and projects that emulate the real-world experiences.
These include technical staff meetings, design reviews, job interviews, formal presentations to a customer, and much more.
Professional organizations from all industries operate on context-based retrieval principles.
Corporations employ internship programs that groom future employees by immersing students into the real-world business environment.
The U.S. military similarly adopts the train like we fight mentality, understanding the necessity of training environments that emulate real-world contingencies.
In Milestone C, we developed the nonlinear learning model with the same principles in mind, based on the following three philosophies.
Controlled chaos is a highly effective learning environment. 21st century STEM professionals work in cross-functional teams, and progress takes effort.
Traditionally, in education, we eliminate the potential for miscommunication, competing objectives, confusion, and even reasonable frustration among students in an effort to keep class orderly and on schedule. In doing so, however, we also inadvertently eliminate the most valuable teamwork lessons.
Project-based programs that oversimplify teamwork as a group of students working in the same task at the same time fall short of achieving meaningful learning objectives.
STEM industries in corporate America utilize the cross-functional team construct where individuals work on their own independent pieces of a project at the same time as others work on theirs.
And the true challenge in teamwork lies in bringing those different pieces together toward the achievement of a common technical goal while staying on budget and schedule.
All Milestone C programs adopt the same cross-functional team structure, intentionally leverage the challenges it presents, and enable teachers to maintain an environment of controlled chaos as a teamwork laboratory which grooms future leaders.
Hands-on teaching or non-intervention is the single best facilitator for hands-on learning. Very often, students are handed a complete box of parts and step-by-step instructions in a sincere attempt to facilitate hands-on, project-based learning. Unfortunately, the results of giving the students the complete, accurate resources is quite the opposite.
We call this the IKEA model. Yes, at the end, the students have completed the project with their hands, but did they practice the critical thinking? Did the project-based nature of the activity actually contribute to their learning, or was it an outcome more analogous to assembling an IKEA bookshelf?
In the professional environment, it takes research to get that information. Even then, data might be unclear, untimely, out of order, maybe even conflicting.
Allowing students to obtain, filter, prioritize, and process information without frequent interjections is critical to broadening their horizons and allowing them to learn through experiences in hands-on projects.
To that end, Milestone C projects provide students with equipment and raw data, the use of which are not immediately obvious.
This approach forces students to delegate, test, inquire, analyze, and decide how to keep a project progressing.
In the process, they learn, they apply key college and career skills that will be useful in any career.
That is the value we offer with STEM programs designed directly by Fortune 500 professionals and vetted by seasoned educators.
Under nonlinear learning, what we call rewarded failure is a model where students are assessed on critical thinking, problem solving, process, and application of knowledge, as opposed to technical acumen of the technical success of their project.
Engineers' role in the tech world is to constantly fail, learn from their failures, and eventually reach a solution.
And most of their time is spent failing and learning until they finally meet the project objectives.
We want students to begin to emulate that process.
Grading the end result, technical success of their project, would only apply if the goal was to graduate many engineers and scientists from middle and high school.
That is not the goal of secondary education. Our objective is to prepare students for success in life.
As facilitators of STEM programs at the secondary education level, we are creating learning environments that provide students with exposure and experience the day-to-day life of technology career tracks.
In doing so, our programs also equip students with the foundational skills necessary to excel in 21st century tech workforce.
Getting students comfortable solving problems without a single correct answer requires giving them room to fail, which goes against most career educators' training.
However, encouraging innovative approaches by grading problem-solving processes, motivation, and application as opposed to grading end results is the only way to foster critical thinking through project-based learning.
And as such, shaping future STEM professionals begins with allowing students to fail and enable them to learn from those failures without the fear of the poor grade.
In summary, students working hands-on and following instructions is not nearly sufficient to set up an environment of genuine project-based learning.
Similarly, students working in teams on the same tasks at the same time doesn't mean that they're practicing teamwork.
Finally, associating grades with the outcome of a project only serves to steer students away from innovation.
Milestone C's nonlinear learning model is the product of more than 100 years of combined leadership experience at Fortune 500 tech companies.
This model mitigates common shortfalls in project-based classes and creates experiential learning environments with 3 clear outcomes.
Emulating real-world industry practices.
Equipping students with foundational skills.
Shaping future professionals and leaders.
This concludes our introduction to nonlinear learning.
We encourage you to revisit this video periodically throughout the school year. As you gain experience teaching our programs, you will gain new perspective on the various aspects of nonlinear learning.
And while it is critical to understand and apply our nonlinear learning model to properly implement Milestone C programs, we also hope that you will find this model helpful in developing your own STEM programs organically.